Hey, this is Keith. I'm going to show you how I 3D printed an intake manifold. So the airbox that I started with is designed to adapt these 2 3/4 inch inside diameter throttle bodies that my dad built to a standard carburetor flange style intake manifold. It's a 4150 pattern on there. It's made out of 1/4 inch aluminum on the bottom and some 1/8 inch aluminum for the sides and top, just MIG welded together. It's one of my first aluminum MIG weld projects. This is set up for a fuel injected manifold, so we've got throttle position sensor, idle air control motor here, housing pulled off of a different 3rd gen Camaro and welded on there, intake air temperature sensor, a couple of ports for like your fuel pressure regulator and map sensor. This manifold box worked pretty good, no problems with it, that never blew up or anything. The engine probably easily made 1,000 horsepower on it, but a couple of challenges with it. Obviously the airflow has to make this 90-degree turn, and the box is not set up to make that a streamlined path. Also, these front holes, the screws to screw this down to the manifold, are obviously inside the box. I never had them come loose, but the challenge was more getting them loose, and the fact that you have to take everything apart to get to those screws if you wanted to take the box off to look at anything. So in designing this airbox to be 3D printed, the number one thing I wanted to take care of was smoothing out that airflow. So I started with the circle that's the inside diameter of the throttle body, and then half of that opening into the intake manifold down there, and lofted a shape that gave me control over the short side radius here, and the way the flow changes shape from, obviously from a circle to more of a D shape there. So I started with this shape because that was going to be the easiest way to model the rest of the part. Then I thickened that part out so that we had some material there to work with, and then mirrored it, added bosses here and holes to bolt those throttle bodies to it, added a throttle cable bracket, bosses for sensors and things like that. And one thing I did to address the bolt hole through the air passages was added this hole in the center in between the two of them. And I figured while I was doing that, I might as well build a triangle pattern around there with the bolt locations as close to this perimeter as possible, to make sure that they could hold the box down securely and not break anything off. So all 3 of those holes are actually in different locations than the original carburetor flange holes. So since I was going to be 3D printing this, I obviously had to pick a material that was resistant to gasoline, to ethanol, because I usually run Flex Blend. Also something that could take the heat of being under the hood, and also that could take, have some strength at those elevated temperatures, since, again, supercharged setup here, not with a high amount of boost, but I want to make sure that we don't blow the thing up. So one of the materials I found that was compatible with a lot of those requirements was polycarbonate. Polycarbonate's a bit trickier to print on a 3D printer because instead of printing at 200 degrees Celsius like entry-level materials, it prints at 300 or more. Also requires an enclosed build chamber, requires a heated bed plate, pretty hot environment to print it and have it come out well. So you see my 3D printer behind me. It's a pretty inexpensive printer. It's a $200 FL Sun Cube printer with some modifications to it. Some of those modifications include upgraded extruders, a all-metal hot end, a bed sensor to square things up a little bit better. Obviously an economy job here of enclosing the printer with a blanket and kind of boxing it off to keep the heat inside. The bed on this printer right from the factory didn't have any trouble going to about 110 degrees C, which is good for the polycarbonate material. And with the all-metal hot end, I didn't have any trouble cranking that up to well over 300 as well without melting anything. Alright, so the material I printed the first print with was a polycarbonate material. This came off of Amazon. It's kind of a knockoff material. That's why it says polycarbonate. It was about a $35 spool of material, which is a kilogram. It's about enough to make probably 2 of these boxes without any trouble. The first print that I did with this, I'll talk about the print defects first here. You can see a line right about here and another line down here. These are areas where I had the filament jam on me, and so then I had to go in, slice the G-code up, bring the print head back down, clean everything off, restart the print, work my way up. So I did that twice, just printer tuning problems with the new filament. But otherwise, turned out really neat. You can see when you rotate it here, all those little curves that got turned into line segments. Kind of a really neat effect on the print. Strength-wise, pretty strong print, even with those relatively thin walls there, so no problems there. I printed this with the slicer building the support for it, so that was a little bit of a challenge to remove. I'll talk in some of the later prints about how I got over that, but not a bad first print. Now, so when I went back to the CAD for the second version, I wanted to try a couple of things. I added a little bit of material to the throttle cable mount. The first version seemed pretty strong, but I just wanted to add a little there. Also, when I had the box on the intake manifold, it just looked a little bit small, and most of that was because it didn't cover the top of the flange. So I brought this out a little bit, and I moved the tabs back from my alternate locations to use the factory carb back hole locations. That way I wouldn't have to drill 2 extra holes in the manifold, and it would cover a little bit more, like I said. So I also wanted to take a shot at adding the idle air control motor back into the design. So I built a boss for that with a port that I could thread up front to bypass the throttle bodies since this is supercharged. And also, since I didn't have an M20 tap, I drew in the threads and experimented a little bit to get the size right on those. So this is the second design print. The print turned out with no defects. Material printed really nice. Temperature stayed nice. But design-wise, I had been testing this idle air control boss just as a piece by itself. And the way it was cooling and shrinking was a little bit different than when I printed it as a part of the whole airbox. So it didn't shrink as much, and so, those threads don't fit. I also, since I had this part and I was getting close to something that was workable, I took it and I set it in the oven, cranked the oven temperature up to 250 degrees, and I was expecting this material to be pretty firm because it's supposed to be polycarbonate. But even at 250 degrees, I could put my hand on here, and with a decent amount of pressure, but I could squish it down. I mean, it was starting to get springy. So the material that I was using, I know it was a little bit more on the cheap end, and so I probably was getting a polycarbonate blend, had some other plastics in it. That's good because it makes it easier to print, and it's probably why I got, such nice prints out of it. But with it not being 100%, I couldn't guarantee that it would be chemically compatible and not melt or break down with alcohols and gasolines. But I also probably didn't have the strength or the temperature resistance, obviously, that I thought I was going to have. So for the third version of this part, I didn't make any changes in the CAD, but I did find an alternative material, since that polycarbonate wasn't going to cut it, at least the fake stuff I had. And this is a nylon material, fiberglass reinforced, so it's 30% fiberglass in there. It's supposed to have really good heat deflection properties. It's also very similar to what a lot of current plastic car intake manifolds are made out of. It's a bit pricier. It's $68 for 3/4 of a kilogram. So it's right on the edge of the amount needed to make one of these boxes. Now the other challenge with it was really tricky to print. And especially with my printer, I didn't have settings to go off of, so I had to work a lot and figure out what was going on. With this first print, I was getting it to stick to the bed pretty good, but I was getting a lot of junk hanging off of it there. I was also printing this with a brass nozzle, and with the fiberglass in the material, it's really abrasive. And so I'll show you what the nozzle looks like I was printing with. On the left is a used, but not used for this material, 0.8mm nozzle. And on the right is the nozzle I was printing with. The tip, from being drug over the print with all this junk hanging up, actually ground the tip right off there. And then the hole enlarged. Part of that is because inside, as the nozzle got shorter, is bigger. But also did enlarge the hole itself a little bit too. So I got some more settings dialed in with the material, starting to look a lot better. There's still a lot of this fluffy junk on there, but this was an example where the sides were starting to look much nicer. Good solid fill. Had a little bit of trouble under extruding there. And then I printed this one. Still, settings are even better. Got rid of that under extrusion problem mostly. And then I tried, actually I printed this upside down here, this way. I wanted to just double check that I could print thin overhangs. But this was looking much better. Now, if you can see that rocking a little bit there, this was warping quite a bit. So I was printing this on the aluminum bed with the Kapton tape on there, and it was warping so much it was actually pulling the tape up off of the surface. So I knew I needed to solve that problem. Definitely by using kind of more like this one, using a full bottom layer to keep the part stuck on there, and then getting a good wide brim around it too. So I swapped out that brass nozzle for the steel nozzle I mentioned earlier in the printer topic, and then I printed this full piece here. Printed out pretty good. The biggest problem with this one, it's actually one of my better ones as far as no defects, almost all the way up here. I'll talk about this one a little bit later. But when it got up to these tabs, once we got above the height of this boss here, it would print this little rectangle and then a little rectangle here over to the other side, do the same thing, and then work its way back and forth. It spent so little time, of course, printing these, and I didn't have a minimum layer time set that would have prevented it from continuing to go back and forth, that it was just starting to melt them off. And so I tried a couple of times to stop the print and trim these off and then restart the print down at that level, but I couldn't get it to re-adhere well enough. And when I would put in a minimum layer time, then the material would ooze out of the nozzle, and without the right amount of prime, there would be nothing left in the nozzle, so it would try to print that tiny rectangle and nothing would come out of the nozzle. So obviously that's a settings problem, because a printer with all the right settings might be able to print those. You might even need a layer cooling fan at that point. But I didn't have that, so I decided instead that I would make some design changes to the next design. The other thing on this one, I did experiment with drilling and tapping these things, and really just make sure this would fit well. In drilling and tapping this pipe fitting here, this is a 1/4 inch pipe, and in winding the fitting in, it's hard to see, but on the very top I ended up splitting that housing. So that's just one more thing. I thought, okay, well in the next version I will just make that a little bit thicker, and then of course try to be careful winding in anything that's tapered, because it generates a lot of force. You don't need that much to seal it, and you don't want to split whatever it is you are winding it into. Alright, so when I went back to the CAD for version 4 of this part, I quickly took these tabs in the back, connected them with a straight across section so that that was a solid piece. That way when it was printing, it'd be printing a long area, and there'd be more area for the heat to go into. I wouldn't be melting off those little tabs. The other thing I wanted to talk about quickly was the support structure. So for these upside down surfaces here, normally you'd use the slicer to generate support, but when I do that, it generates support all the way down to this surface and makes a mess out of that surface, and all the way down to the base plate. So that's like 5 inches of support it has to build to get up to that surface. Same for this surface. It's, I don't know, about 3.5 inches up to this surface. And it's a pretty small surface. You could almost get away with bridging it if you didn't care what it looked like underneath. So what I did instead, to try to make it as simple as possible, was I just designed the support right in the CAD. I built off of the model so that there would be no support, and then it would just grow out of the side of the model when it was up high enough that it needed to start building like 45-degree structures out. I could build just what I needed to be able to bridge. And I think I chose about 200 thousandths for the distance between those spans, so I had no trouble bridging it with the material. They were easy to remove because I only needed a razor blade across these little sections here, and took up the least amount of material. Other than that, I don't think there were any major changes to this. I thickened up this boss like we talked about, and just in refining a little bit, I was able to get all the fillets in around here to try to make it look really nice. So this was how the fourth part turned out. I got my flange up here straight across, no trouble printing it. Larger boss over here, didn't crack when I threaded in the pipe thread. Pretty good print. This one was actually good enough that I siliconed it onto the car. I did the heat set inserts up front. They were a little bit tricky to do because this print was kind of warped. But I got them on there. I got the parts sanded up well enough to bolt this on the car and use it. So I idled the car up to temperature and wasn't having any trouble with it. Aside from the throttles were just a little bit misaligned, so it was idling a little bit high. I drove the car around in the driveway just a little bit, and then I managed to stall the car, and when I went to refire it, I had an intake manifold backfire, and it actually blew out the side of the part. So I heard the big pop. When I looked under the hood, these pieces were nowhere to be found. Box just looked like this, right? So I guess I lucked out in a way. It was a pretty awesome test. Any literature I could find estimates intake manifold backfires can be, around the order of 100 psi. That's far more than any boost pressure numbers I would see with the car. And so it just kind of gave me an indicator of, A, what's it look like in here? B, how would this thing fail? And C, what kind of pressure should I expect it to take if I had it on there built the same way this one was built? So when I took it off, I ended up splitting it apart the rest of the way to take a look at whether I thought each layer was fusing to the previous layer well enough. That doesn't look great to me. I think there could be some better layer adhesion there, so I ended up moving the temperature up about 10 degrees on the next prints. And I also took the opportunity to thicken the part up. Again, I was starting to buy more material, so I wasn't worried about trying to finish it in one spool. So I figured I would thicken the part up some. The way this part is built, it's always going to be weaker in this direction. This is the layer adhesion direction, the Z direction. So that's just a challenge that is always going to have to be compensated for, either by making the walls thicker so there's more surface area for that tension force to pull on, or by reinforcing in some other way. So I went back to the CAD one more time, and the first thing I did was thicken this surface more than it was before, so we have a thicker section the whole way around. I also extended these bosses around the heat set inserts, added some strength there. I thickened the bottom flange too. I think I bumped that up maybe a 1/16 of an inch or so. I added some ribs in this area too. They were a little bit challenging to model, but I thought they looked kind of cool, and they would add a little bit more surface area to the section all along here. I didn't want to do it at first because I knew it was going to have to be asymmetrical with the throttle body bracket over here, but I think I came up with a good way to kind of make it look like they were similar without having this one extend all the way through. I also closed in this bottom surface here. This was kind of challenging to do in the CAD. Before, there was a tiny gap that extended all the way down into this recess here, but I was able to close that up and then fill it all the way along here. Again, I wasn't worried about material use anymore. I'd already used more printing these things than I was going to use printing any one more. So I just added it in anywhere I thought that it could be useful. All right, and this is the print result from that final set of design changes. This print took 20 hours, I believe. A couple of defects in it. There's an issue I ran into here. I had the rapid speed set too high on the printer, and that caused the head, when it was making a longer distance move, to run into some debris on the print and knock the X and the Y axis out of sync. And then it printed about 1/4 inch of material on top of this, offset to the side, like when you get a layer shift. So I got lucky. I was able to knock that material off of there. take the print back down where it should be, adjust the G-code, and get pretty good layer adhesion, I think. Obviously, it creates a pretty bad looking line across the whole print. But this wasn't quite perfect anyway. For some reason, there was some pieces that didn't melt out, or maybe this was where a layer ended or something repeatedly in that area. So it doesn't look quite as nice as some of the other ones. The inside turned out nice. Warping was really limited. Top printed without any trouble. I was able to drill and tap all the fittings in this without any trouble. Ribs turned out really nice on there. The heat set inserts, I did a much better job on these than before. With the part shrinking a little bit and a little bit of warping happening no matter what you try to do, when I designed with these holes built into the part and a little bit undersized, of course, so that I could drill them out, they were never quite square. And I mean, the best thing to do would probably be to put this in a milling machine, and then you could precisely drill these holes in and even use the milling machine maybe to push the inserts in so they stayed nice and square. In the previous designs when I did this, I just tried to do it by eyeball. I drilled them out and then just stuck the inserts in, hoping they would square themselves up to the part. Of course they didn't, and then when I went to bolt the throttle bodies on, I had trouble with the holes lining up and it wouldn't clamp down right. So this time instead, I took the time to carefully sand this face and get it as straight as I could. And then I put the throttle bodies in place and found the best place that I thought that they should be and clamped them to the box. And then with them clamped into the box, I drilled using the same drill that I used to drill these. I drilled into the plastic and then repeated that for all of them, making sure I was really careful to keep the part clamped really nice. Now with that done, I had holes that were right where I wanted them. Then, of course, the holes were too small for the heat set inserts, so I carefully stepped those holes up one drill letter size at a time until I had them up to, I think it's letter O. And then I heated the inserts up using the soldering iron like before. And then I would push them in and then quickly flip the part down on the glass bed and hold it down. And that way the heat set insert would, because they tend to like push out, would push out and be nice and square with the front face, and hopefully would be concentric with the hole as well. So I think they went in there really nice. The throttle bodies bowled up to this really nice, and since I have this, you know, as planar as possible, the throttle bodies don't bind and they clamp up pretty well there. But that took a little bit of trial and error a couple of times to learn how to put these in best when you don't have a milling machine handy. The bottom surface, just gave that a quick sand with the power sander and then a little bit by hand to square it up. Didn't have to be perfect anyway because I'll put a bead of silicone around that this will sit on top of the manifold. This area here got a little bit tight. If I print this again, I'll loosen this up so that my cap screw drops through there a little bit easier, but it does work as is. Alright, and that's what it looks like with the throttle bodies bolted up. Used a little bit of black silicone in this connection here, just to seal it up real good. A little bit of Teflon tape on the intake air temperature sensor and the 1/4 inch fittings. I left the idle air control valve as is. It'll seal up just fine. And a little bit of Teflon tape on that -6 fitting for the bypass. Use some black silicone on that bottom up against the manifold, and then they'll have a nice smoother path for that air into the engine.